Okay, this is the second part of the video to answer one of the questions in homework 9 for 285, which is initial conditions or initial values. And initial values are found for t less than 0, so at 0 minus and at 0 plus. We already found the 3 volts and the minus 2 milliamps. And now, even though I'm going to draw from the original circuit, I don't know where the original circuit is here. From this original circuit, I'm still going to draw the capacitors and inductors. Now I'm considering this t larger than 0. Oh, it's not fitting here. Okay. So I'm going to draw up there like this, and I'm going to draw this at t larger than 0, how it looks. And what happens is this switch finally goes up. This part of the circuit now gets out of the circuit, so this becomes its own loop by itself, but this capacitor is not connected to that anymore. So I'm not even going to draw it, but if you're ever interested in the current or voltages around this, oh, maybe I do need to draw it. Never mind, I will draw this. Yeah, and I'll explain why later. So, yeah, what happens is this 2K has a current here, and that means I need this mesh current and this mesh current in case I'm going to do mesh analysis or nodal voltages. So let's do this. Capacitor, 5 volts, 8K. What happens is now this part is outside, so this switch opens, so these two are out of that circuit, but I still have the inductor there. And that is connected to the 2K. And that's why I cannot get rid of that one. And this is like 3K. Actually, instead of 3K, I'm going to put that minus and plus 10. I'm going to tell you the 5K, the 10 volts, and the 3K are in series, so I'm going to call this guy 8K for the 3 and the 5. This is minus and this is plus, and the current's going down. And this is 0.2 milli, and this guy is 0.1 micro, which is 10 to the minus 7, and this is 8K. And this is 10 volts. Okay, so this is the circuit, and what I am gonna now consider is that this current here is minus 2 milli, and this voltage here is 3 volts. And what I'm interested in finding is this voltage, VL, and this current here, IC. So if you go around this IC, you're going to hopefully find that this is also this IC. So if we go around this node, this loop, IC is this one, and it's the same as this, and it's the same as this. I can deduce, hopefully it's easy to see, that IC of 0 plus is IL of 0 plus, which is minus 2 milliamps. Then I realized this is very light color, and then I can use this IC is C dV dt, and I'm interested at 0 plus, and therefore dV dt at 0 plus will be minus 2 divided by 0.1 microns is 10 to the minus 7. So dV at 0 dt will be minus 20 mega. I always make this mistake. Minus 2 milli, minus 20 kilovolts per second. This is our first part of the t larger than 0. I still need to find d I dt, and to find that I need this voltage here. And put the circuit away. So now it's when we can use, for example, KVL, except there is a voltage drop across the 2K. So if I do KVL here, so first let me say how to find VL. So for example, KVL on top mesh, or even on a loop. Here's what happens. I'm gonna start from the bottom left, and I'm gonna have 5 volts plus 8K times minus 2 milli. That's the voltage drop across this guy, plus VL, plus 2K times I2. So if this is I2, I need this voltage drop, which I don't have, plus 3 equals 0. So what happens here, it's 8 minus 16 is like minus 8 plus VL plus 2K I2 equals 0. VL will be 8 minus 2K I2. If I find I2, then I find VL. And to find I2, one way is to use mesh analysis. What happens here for mesh analysis, I will call this guy mesh A, and I'm going to call this guy mesh B. What happens is the current A is minus 2 milliamps because it's defined by that inductor. So I'm going to write the mesh equation only for mesh B. And that's going to be 10 plus 10K IB minus 2K IA equals 0. But I know IA, so it's going to be 10 volts plus 10K IB minus 4 equals 0. Oh no, it's, let me see, plus 4. I'm sorry, minus 2 here is plus 4. So it's minus 2K times minus 2 milli equals plus 4. So 10K IB is minus 14. And therefore, IB is minus 1.4 milliamps. Once we have IB, I can find I2. So hopefully you all remember mesh analysis, like I2 is IA minus IB. And now I have both of them, turns out. I2 is minus 2 milli plus 1.4 milli, which is minus 0.6 milli. Now I can go back and find VL. So now I'm going to use this guy and come here. I'm going to copy that because it's looking too hard. So 2 times 0.6 is 1.2. So this is like 9.2 volts. So that's my VL. The whole point of finding VL is that we can use now VL equals L di at 0 plus dt. So running out of space here. Di at 0 plus dt will be 9.2 divided by 0.2 milli. It's like times 5, 45, 46 maybe, 46 kilo amps per second. I hope this is clear. But if not, please ask me in comments. Feel free to or send me an email. I really hope this combines for you like MASH, Ohm's law, and no diffie-Q necessary. So if for this homework assignment for initial conditions, a lot of people attempt to use diffie-Q, but really these two things here are the last ones you want to use. So you want to use these two last expressions, but really, so you only need IC and VL. I hope this helps clarify what initial conditions are. Sorry for my doing this in the morning here.